An example of mesh analysis. Question: determine the current IS. It's the current of voltage source in the middle. Let's analyze that circuit using mesh analysis. First step is to define some mesh currents. How many meshes are there in this circuit? First mesh, let me say I1. Second mesh, I2. Third mesh, I3. There are 3 mesh currents, 3 meshes in that circuit. The second step, first step was define mesh currents. Second step is define voltages of components. Voltage of this component is 10, it's obvious. And let's define a voltage for that component, V1. Voltage of this component is given already. Let me say V2 and V3. Then write voltage current relations of the components. What I mean is this. What's V1? V1 is the voltage of this resistor, which is equal to R times I. Resistance is 1 ohm. Current is Ohm's law, except the current is entering from the positive side of the voltage. So I1 is the current entering from the positive of V1. So I will say I1, okay, and there is another mesh current flowing on that component, which is I2, but it's entering from minus. So the I2 opposes the current on this resistor. Then I should say minus I2. It means the total current on that resistor is I1 minus I2. And then what's V2? Can you help me? V2 is this 3 ohms times the current on it. There is only one mesh current, I2. And what's V3? Resistance times the current on it. If there is only one current, I will write directly. If there are 2 currents, there can be 2 currents at most. I will add the supporting current, I will subtract the opposing currents. Okay. Then the next step is apply KVL on meshes. Let me copy my circuit and then apply. Okay, on mesh 1, can you help me? Start from a point and continue on, follow on the components to reach the same point. There is a voltage increase of 10. Voltage increase of 10. So I will say plus 10. Continue. There is a voltage drop of V1. Voltage drop from positive to negative. Minus V1. What's V1? Look, V1. V1 is 1 times I1 minus I2. Okay? I1 minus I2. Then continue. There is a voltage drop of 20. From plus to minus, there is a voltage drop of 20. And I have reached the same point. I will say summation is 0. Then, the second mesh equation. Start from a point. There is a voltage increase of V1. From minus to plus, it's a voltage increase. V1. V1 is 1 times I1 minus I2. Remember, no need to write 1 times. Okay, multiplication with 1 is not changing anything. Then continue on that loop, plus to minus. It's a voltage drop. Minus V2. What's V2? V2 is 3I2. 3I2 is the voltage of this resistor. Okay. And continue. Oh, I haven't defined a voltage on that of that resistor. Let me say V4. But I2 is entering from the negative of V4. So let me change this side negative, this side positive. Okay, it's up to me. I can select any direction. It's not important actually, but let me select in that direction. So there is a voltage drop of V4. Voltage drop. What's V4? I will say minus V4. Let me define V4. V4 is, look at the circuits. Let me write V4 here. Minus V4 plus. V4 is resistance times the current, supporting current I2, opposing current I3. Okay. So I will write 2 times I2 minus I3, and then I have reached the same point. Summation should be 0. Then the third mesh equation is, start from a point, continue, voltage increase 20, continue, voltage increase plus V4. V4 is 2 times I2 minus I3. Continue, there is a voltage drop of V3 minus V3. What's V3? 4I3. 4I3 is equal to 0. How many unknowns? 3 unknowns. How many equations? Number of unknowns is 3. Number of equations 3. So that set of equation can be solved. Okay. I don't continue anymore because the following part is math.